Okay, in this video we're going to take a region and revolve it about the y-axis. So instead of the x-axis, let's revolve this about the y-axis. So my region is bounded by y equals x cubed, y equals 8, and x equals 0. So that's going to be the y-axis. So this is my region right inside here. I'm going to revolve that about the y-axis. So I'm going to try my best to duplicate this region about the y-axis, which would give me something kind of like that. I want to make this look somewhat three-dimensional, so let's see if I can do that quickly here. Let me actually not do a fill here. Okay, so it's going to look like this, three-dimensional. I would fill all this in. So I would have this three-dimensional shape. Looks very similar to the one in the last video. Again, it's a solid figure here. And so again, I'm going to use discs, the disc method, to figure this out. But as you can maybe see, the way that the circles are going to be oriented is different from the last video. So the last video we looked at if these circles were oriented essentially vertically, and I stacked them horizontally. Well, now all these circles are going to be oriented. If I were to slice them this way, they're going to be oriented horizontally, and I'm going to stack them vertically. And I would keep slicing them, stacking them, and so forth. And I would keep stacking these circles until I get that solid volume of that shape. Okay, so what's the difference here? Well, the difference here is that if I revolve about a vertical line, like the y-axis, my functions, my radius is what I should say. My radius is going to be determined this way, horizontally, and that means that my function needs to be not in terms of x, but now my function needs to be in terms of y. So what I'm going to have to do is I'm going to have to take whatever function I have, if it's defined in terms of x, I'm going to have to solve that for x so I can write it in terms of y. So I want to think of this as x equals the cube root of y. Okay, and that's how I'm going to think of this red curve, as x equals the cube root of y. Now, in terms of how I stack these up, I'm still thinking pi r squared. I'm still thinking the area of a bunch of circles. Area of a bunch of circles added from my first circle is going to be down here at 0, and my last circle is going to be up here at 8. So that gives me the bounds of 0 to 8. Again, I'm just going to take all the pi r squareds, all the areas of the circles, and add them up. So I'm going to have pi times the radius squared. Now the radius this time is always going to be from the y-axis out to the function, and again, if my radius is determined that way, then I need to have it in terms of y. So I'm going to think of my radius as being the cube root of y. So I'm going to take the cube root of y, I'm going to square that, pi r squared, and I'm going to do dy. And again, this one would involve some simplifying before I take the integral. The cube root of y squared, I can rewrite that as y to the 2/3 power dy, right? It's always power over root, so my power is 2, my root is 3. And now we are ready to integrate. So I've got pi times the integral of y to the 2/3 would be y to the 5/3, 3/5 of that, evaluated from 0 to 8. So we have pi times 3/5 times 8 to the 5/3 minus 3/5 times 0 to the 5/3. Okay, so 8 to the 5/3 power. So that means I'm going to do the cube root of 8, and I'm going to take that to the 5th power. So the cube root of 8 is 2. 2 to the 5th power is 32. So I have 3/5 times 32 minus, this is just going to be 0. Okay, 3/5 times 32. Well, I can just make that 3 times 32, which would be 96 fifths. And then I'm just going to multiply by pi, and I'm going to get 96 pi over 5. Again, it's a volume. If you want to say cubic units, that's what you would go with. But we're done. Okay, so that's if we revolve about a vertical line like the y-axis. It's going to be in terms of y. I'm going to integrate with respect to y. But it's essentially the same disk method as before, just with y's instead of x's.